Your API already works for humans, but can AI models actually use it effectively? We'll transform an OpenAPI spec into an MCP server with proper authentication, showing how to bridge the gap between REST APIs and AI clients while maintaining security. The pattern handles token-based auth and request timeouts in just a few lines of code. Import HTTPX. From FastMCP, import FastMCP. Hash bearer token authentication. API client equals HTTPX, async client. Base URL, HTTPS, API example com. Headers equals authorization, bearer your token. Hash create MCP server with authenticated client. MCP equals FastMCP from OpenAPI. OpenAPI spec equals spec. Client equals API client. Timeout equals 30. 0 hash 30-second timeout for all requests. This demonstrates the OpenAPI to MCP bridge pattern, where an existing REST API becomes instantly accessible to AI models through the MCP protocol. The pattern converts OpenAPI specifications into MCP components automatically, creating a translation layer between traditional HTTP APIs and AI-native interfaces. What makes this distinctive is its ability to preserve the full functionality of REST endpoints while making them discoverable and callable by language models without manual wrapper code. The approach works through declarative mapping between OpenAPI roots and MCP component types, using a priority-based system where specific root patterns override general ones. Authentication and request handling remain decoupled from the conversion logic, allowing the original API's security model to stay intact while the MCP server handles protocol translation. This separation of concerns means you can expose APIs to AI clients without modifying the underlying service or writing custom adapters for each endpoint. This pattern solves the integration gap between legacy APIs and modern AI systems, eliminating weeks of boilerplate development for API wrappers. It's particularly valuable when you need to expose existing services to AI agents quickly, or when maintaining parallel REST and MCP interfaces would be cost prohibitive. The trade-off is that auto-generated MCP servers may not be as optimized for AI workflows as handcrafted ones, making this ideal for prototyping, or when API stability is more important than perfect AI ergonomics. Let's break it down line by line. Import HTTPX. Imports HTTPX, the async HTTP client library. Handles all network requests to the API with support for async await syntax and connection pooling. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools. It transforms Python functions into structured APIs that AI models can invoke, handling serialization, validation, and execution. Hash bearer token authentication. API client equals HTTPX, async client. This initializes an async HTTP client with HTTPX, the foundation for all API requests. Bearer token authentication will be configured next, securing every outgoing request through this client. Base URL, HTTPS, API example com. Sets the root API endpoint for all requests. Eliminates repetitive URL construction by making all paths relative to this base, so you only specify endpoints like users instead of full URLs. Headers equals authorization, bearer your token. This sets the authorization header using the bearer token scheme, the standard for API authentication. It ensures every request includes your authentication credentials, preventing unauthorized access to protected endpoints. This closing parenthesis finalizes the FastMCP initialization, locking in the configured client, timeout, and OpenAPI spec. Without it, the object creation remains incomplete, preventing any tool registration or API calls. Always verify matching parentheses in complex initializations.
Hash create MCP server with authenticated client. MCP equals FastMCP from OpenAPI.
This instantiates the FastMCP server using the OpenAPI specification. The from OpenAPI factory method binds the preconfigured authenticated client to the server, ensuring all requests use the same authentication and timeout settings. This is the standard initialization pattern for FastMCP when working with OpenAPI-based services.
OpenAPI spec equals spec.
This passes the OpenAPI specification to FastMCP, defining all available API endpoints, parameters, and schemas. The spec dictates how FastMCP translates Python calls into proper HTTP requests, ensuring type safety and validation against the API contract. Without this, the client wouldn't know what operations are available or how to structure requests.
Client equals API client.
This injects the preconfigured HTTP client into FastMCP, ensuring all API calls use the authenticated connection and shared timeout settings. Dependency injection pattern centralizes client configuration in one place, eliminating duplicate setup across tools.
Timeout equals 30. 0 hash 30-second timeout for all requests.
This sets a 30-second timeout for all API requests, preventing indefinite hangs when the server is unresponsive. FastMCP applies this globally to every call made through the client, ensuring predictable failure modes instead of silent stalls. Closing parenthesis terminates the FastMCP. From OpenAPI, call, finalizing the MCP server instance with the configured client, spec, and timeout. This is the standard builder pattern completion. All parameters are now locked in for the server's lifetime. Authentication integration pattern. The HTTP client configuration in FastMCP 2 demonstrates how external authentication systems become transparent to the MCP layer, with all security handled at the transport level before requests reach your tools. A missing or expired bearer token will manifest as 401 errors from the target API, not FastMCP validation failures. This separation of concerns lets you swap authentication mechanisms without modifying your MCP server logic.
The server that knows no secrets guards all secrets.